Hello, students. So my name is Swayam. I'm a student in AIIMS Bhubaneswar and pursuing my MBBS. So we'll start a new chapter today. We have completed chemical kinetics and atomic structure previously. So hydrocarbons is the most basic chapter of your organic chemistry. Okay. So you have to be thorough with this chapter. Okay. So let's focus on the PIQs here. Let's start. Every year you can get one or two question from this chapter, so you have to be thorough with this chapter. Okay, so question number one will start. Question number one: the alkane that gives only one monochloro product on chlorination with chlorine in presence of diffuse sunlight is. Okay, so here it is asking about the chlorination reaction. Okay, you know the chlorination reaction is a free radical like halogenation reaction of hydrocarbons, specifically alkanes. Okay, it is a free radical mediated reaction. In this reaction, what happens? The the chlorine free radical substitutes the hydrogen atoms present in the hydrocarbon. But for the numbers, like for determining the number of products, we have to calculate the unique hydrocarbons, unique hydrogen. Okay, what do you mean by unique hydrogens? Means if we take an example, this suppose let's draw the ABCD option structure. Okay, in A it is given isopentane. Isopentane structure means this. I am writing the skeletal form 1, 2, 3, 4, 5. Okay, it is isopentane. Option B given 2,2-dimethyl butane. Butane 2,2-dimethyl. Okay. Option C given neopentane. And option D is given as N-pentane. Okay. So for unique hydrogen positions, you have to look for hydrogen atoms. So where is the hydrogen atoms? Here, hydrogen atoms, three hydrogen atoms, and here three. Here also one hydrogen atom. So tell me, this hydrogen atom and this hydrogen atom position is same or different? Same. This hydrogen position and this hydrogen position is same or different, although these are on the different carbon atoms. But if you go nomenclature wise or structure wise, these are on the same position. Okay, because they are identical branching of from same carbon atom. Okay, they are on the identical branching position, so they are same hydrogen atoms. Although there are six hydrogen atoms here, but all of them have same position. So we'll count as one unique position. Okay. Here hydrogen atoms is another one. That is another unique position. Two. Here it is also another position. So it is three. Although there are two hydrogen atoms in this position, but unique position is three, like one. Okay. So we got three unique position, and here another one. So we got four unique positions of hydrogen in this molecule. That means if we chlorinate it, means if halogenation reaction occurs here, so chlorine would be substituted here. Here one chlorine can be substituted. Here one, here one, here one, and here. Okay. So if we write clearly, hydrogen is replaced by chlorine. In this way, we can get four products. Okay, four products of halogenation in this molecule. Similarly, here we will find unique position for option B molecule. Okay, So these position hydrogen atoms, these three positions are same. So total here unique position one, here no hydrogen atom, here two hydrogen atoms. So there is a second unique position. Here three hydrogen atoms. There is a three unique position. Means three products can be produced. Okay, three products can be there after halogenation. Look at this molecule, neopentane. In neopentane, there is only one unique position. What? Because these four carbon atoms have the same like same unique number. Like if chlorine attaches here, the nomenclature will be same. The name for the molecule will be same as that of if chlorine attaches here or if chlorine attaches here. Okay. For all the four positions, there will be same name or same structure. So there is only one unique position here. So there will be one major product, only one. For N-pentane, there will be, it is a unique position, it is a unique position, and it is a unique position. This position is similar to this position, the terminal position is similar to this. So there are only three unique positions. So three products can be there. These like the three products are monochloro. Okay, monochloro product. There will be more than three products, but only three monochloro products will be there. Okay, so in this question, it is asking that uh, alkane that gives only one monochloro product. So which alkane gives one monochloro product? Only one monochloro product. Option C molecule, that is neopentane. But before going to the next question, let's see the mechanism also for this reaction because it is a very important reaction. Okay. So for the mechanism, it is a free radical mediated. So if you go through the mechanism, there are three steps. That is initiation, in which the chloride, listen, the chlorine molecule will be converted to chlorine free radicals. Then second step, that is propagation. These chlorine free radical will attack the alkane. Let's suppose the alkane is CH4 or C2H6. Okay, it will attack the alkane. Okay, so it will form as C2H5 free radical and HCl. Okay, so a new free radical would be formed, C2H5 free radical. Then it will this new free radical will attack the chlorine molecules. C2H5 free radicals will attack chlorine molecule. Okay, so it will form C2H5Cl plus chlorine free radical. It is the propagation part. Then the third step is termination, in which all the free radicals will uh, react with each other. Like chlorine will react with chlorine free radical. Again, it will form chlorine molecule. C2H5 free radical will react with C2H5 free radical. It will also form C4H10. Okay. This way, the termination of this reaction will occur. For the rate of reaction will be highest for fluorine. Okay, the fluorine will be the highest reactive element, then chlorine, then bromine, then iodine. And for alkanes, it is the tertiary alkanes that will be most reactive. Okay. So question number one answer A will be option C. Question two, the reaction of ethyl magnesium bromide with water would give. So write the equation first. Ethyl C2H5 magnesium bromide. What do we call this molecule? We call this molecule as Grignard reagent. We'll know about this molecule in 12th class. More about the, like in the chapter haloalkane. You will know more. Okay. C2H5 MgBr reacts with water. So what will be the product? Here it will be simple hydrolysis reaction. Means the H plus, the hydrogen like H2O have H plus and OH minus. So H plus and OH minus will divide this molecule here. Okay. H plus will react here and OH minus will come to here. So the product will be C2H6 plus MgBrOH. Okay. So the major product will be ethane. We can use this reaction as a preparation method for obtaining the alkenes. Okay. So the answer would be A. In commercial gasolines, the type of hydrocarbons which are more desirable means commercial gasolines means the fuel. Okay. For gasoline, we use branched hydrocarbons. Why? Because they have a higher octane number than the unbranched or linear. Okay. So branched hydrocarbons have a higher higher octane number compared to linear hydrocarbon. What is octane number? You for now you remember octane number. The higher the octane number, the more efficient or more uh, combustible the uh, fuel is. Okay. So we need more efficient fuels. Okay, we need more combustible fuels. So we'll choose higher octane number fuels. So we will use branched hydrocarbon as a fuel or gasoline here. So here options are given: brass hydrocarbons, straight chain hydrocarbons, aromatic hydrocarbons such as toluene, linear unsaturated hydrocarbons. So option A will be correct. And for branched hydrocarbons, we mostly use one molecule that is 2,2,4 trimethyl pentane. It is the major component of gasoline. 2,2,4 trimethyl pentane. 2,2,4 means it has three branching points. Okay. So let's move on to next question. Question number 4. Which one of the following reactions is expected to readily give a hydrocarbon product in good yields? Okay. So we need to remember, consider the uh, hydrocarbon formation reactions or preparation reaction. Okay. So we'll go one by one with these reactions. Okay. From option number D, we'll start. Option D. The reaction given is CH3 whole 3 CCl reacts with C2H5OH. So this will give an ether. This chlorine would be replaced or substituted by C2H5O. So the product will be CH3C over C2H5. Okay. This will be the product here. So it is not an hydrocarbon, means alkene or alkyne. So option D is not correct. Option C, CH3, CH3, chlorine, HNO. So it is a chemical reactions of hydrocarbons, it will yield CH3, CH2, Cl, or CH3, CHCl2, CH3, CCl3, or CH2Cl, CH2Cl, CHCl2, HCl2, CCl3, CCl3. Okay. These are the products it can produce, but it is not a pure hydrocarbon. So option C is also not correct. Option B, it will be taught in 12th class. So I'm not touching the option B because you can't understand the mechanism here. So let's look at option A, RCOOK, electrolysis, electrolytic oxidation. So it is telling the electrolytic oxidation of in potassium salt of carboxylic acids. So let's see the mechanism here. So for this reaction, the product will be an alkane, but one carbon less than the parent chain. Than the parent chain. Okay. If the parent carboxylic acid had like 6 carbons, then the uh, product alkane will have 5 carbons, less than like one carbon less. Okay. So let's see the mechanism here. It is a electrolysis process. So there will be two electrodes. So there will be two reactions at two separate electrodes. First, look at anode reactions. Okay, anode. At anode, the CH3 means the carboxylic acid will be formed in this way, and it will give two electrons, and it will form two CH3 CO and free radical. And these two free radicals will combine to liberate two CO2. Okay. After liberating CO2, it will form two CH3 free radicals. Okay. These free radicals will combine with each other, will react with each other to form a hydrocarbon or alkane. Okay. This reaction will happen at anode. Let's see the cathode reactions also. Cathode reaction would be the water will be split into OH minus H free radical. And these free radicals of hydrogen will combine with each other and liberate hydrogen gas at cathode. So if the question asks what like which gas would be will be liberated at cathode in this electrolytic oxidation reaction, it will be hydrogen. Okay, you will be confused with alkane, but you have to remember that at cathode it will be hydrogen, and at anode there will be the alkenes. Okay, so the answer will be A. Okay, the electrolytic oxidation of potassium salt of the carboxylic acid would produce an alkane, lesser like one carbon less. So let's move on to next question. Question number 5. Hydrocarbon A reacts with bromine by substitution to form an alkyl bromide. Okay, hydrocarbon A reacts with bromine to form an alkyl bromide, which by Wood's reaction is converted to gaseous hydrocarbon. This alkyl bromide is converted to a gaseous hydrocarbon containing less than 4 carbon atoms, means gaseous alkane containing carbon less than 4, means maximum It can contain three. Okay. So what is Wood's reaction? Let's see the Wood's reaction first. So alkyl bromides, let's suppose CH3Br. Alkyl bromides react with sodium in a medium of dry ether. Okay. The medium is a dry anhydrous ether to produce these alkyl groups will combine with each other. Okay. So it will produce CH3 and CH3. Okay, fine. So uh, in this reaction, like in this question, it is given what is the A? Means A can be RX, alkyl bromide. So who is alkyl bromide can be possible for this reaction? Because A will be alkane. Okay. Here to produce a gaseous alkane less than carbon 3, we have to take alkyl bromide as either CH3Br, it will produce CH3CH3, or we can take CH3Br plus C2H5Br to dissimilar. So it will produce CH3, C2, CH2 and CH3. So there are two possibilities. But here the A is only one compound. So we can't take CH3Br and C2H5Br at the same time, because it is asked, the question is asking the like only one alkane is used. So the only one alkane will be like the derivative of CH3Br, right? So CH3Br will be produced from which alkane? It will be methane. The bromination of methane will produce CH3Br. So the A option, like the hydrocarbon A will be CH4, methane. Okay, option C is correct. Question number C. The total number of pi bond electrons in the following structures. Okay, for pi bond electrons calculation, we have to know, like we have to find the number of double bonds. Okay, because the pi bonds are present in double bonds. So let's find out in this reaction, like in this molecule, how many double bonds are there. If you see, there are four double bonds in this molecule. Four double bonds means four pi bonds. One pi bond contains two electrons. Okay. One pi bond contains two electrons. Then four pi bond. Here we have four pi bonds. So there will be 2 into 4, 8 pi electrons. Okay. So in this molecule, there are 8 pi electrons. Option A is correct. Let's move on to next question. Question number 7. The IUPAC name of the compound having the formula CH triple bond C, CCH2. Okay. Let's write down the molecule first. Draw the molecule first. CH. Okay. So you know that for nomenclature, first of all, we have to identify the principal group, the principal functional group. Then we have to number accordingly, number the molecule accordingly with respect to the principal uh, functional group. Okay. So here there is like no principal functional group is present, but there are double bond and triple bond are present. So for double bonds and triple bonds means YNE, N means alkyne, and double bond means ENE. If in a molecule both double bonds and triple bonds are present, we have to consider the molecule as a alkyne. Okay. So the principal group here is triple bond. But for the numbering part, we have to consider the double bonds. Okay, we have to number accordingly, like according to the double bond. Where the double bond is present, from that side we'll start numbering so that double bond will have lesser number. Okay, lesser positional number. So for this molecule, if we number, we'll number from this side. That is 1, 2, 3, 4. Okay. So it has 4 carbon atoms means but, and the suffix will be yne because we have decided the uh, principal group as yne. Okay. So but 1 ene. Okay. So if I write the funda behind this, the principal group will be yne. That will be used as a suffix, but numbering will be according to en. That is double bond. Okay. So let's move on to next question. Question number 8. Which one of the following alkenes will react faster with hydrogen under catalytic hydrogenation condition? Okay. First of all, you have to know the what is catalytic hydrogenation. Okay. Catalytic hydrogenation means there will be catalytic hydrogenation. What does it mean? There will be catalyst that is nickel, palladium, or platinum, and there will be hydrogenation. For that purpose, we need hydrogen. Just a minute. Ah, so we take alkenes. Let's suppose CH2, CH2. We add hydrogen over finely divided nickel, palladium, or platinum. Okay. So in this reaction, this hydrogen will dissolve this double bond and take their position. So it will an alkane will be produced. This reaction is called catalytic hydrogenation. For this reaction, we need the least hindrance. Means for the reactivity is inversely proportional to hindrance or steric effect. Okay, so we have to find the least hindered molecule here. So option A has RR means a cis position alkyl. Okay. Option B has three R's, like three alkyl groups. Means it has more hindrance than first. So option B is eliminated. Option C has two R's, but at the same carbon atom. Okay, so it is more hindered. Then option A, because option A has two alkyl group, but they are on both, like they are both on the separate carbon atoms. Okay, so option C is more hindered than option A. So option C is also eliminated. Then option 4. Option 4 has four alkyl groups. Okay, it is the most hindered alkene here. So option A is the least hindered alkene here. So it will have the most, it is the most reactive. Option A is will be will have most reactivity. Okay. So option A would be most feasible for hydrogenation. Okay. So But the answer is option B. It is incorrect. I have checked with several other books, and there it is given option A. Here in the slide, it is given wrong. Okay. So cis 2 butene, the option A will have the like most reactivity. Question number 9. Reaction of HBr with propene in the presence of peroxide gives. Means propene reacts with HBr in presence of peroxide. Okay, let's focus it. Okay, so alkene HBr reaction, it is a very popular reaction, but it has two mechanisms. Okay, so first mechanism is without peroxide. I'll discuss the mechanism first, then we'll discuss the answer here. So there are two mechanisms. In absence of peroxide, in presence of peroxide. Okay, in absence of peroxide, if we take propene, here is the propene. Okay, in absence, HBr will be converted into H plus and Br minus. And this H plus will attack the alkene. And it will attack in a way that the carbocation formed will be more stable. So there are two possibilities. It can form this carbocation or it can form this carbocation. But which carbocation is more stable? The first carbocation is more stable because of like the two alkyl groups from both sides. Okay. And then the bromide ion will attack this and it will form a haloalkane. Correct. So there is a general formula for this, that is Markovnikov's rule. You can know the product without doing the mechanism. How? Markovnikov's rule says that the halide ion or halogen will replace the more substituted carbon. More substituted carbon. Okay. So, in this molecule, which is the most substituted carbon atom? This or this? This is the most substituted carbon atom. So the bromide ion will be finally placed here. This is the Markovnikov's rule. You can use this rule for HBr, HCl, HI without peroxide. But in presence of peroxide, HBr reacts differently. Only HBr, not HCl or HI. HBr reacts differently. In peroxide, it will form H radical, hydrogen free radical, and bromine free radical. And bromine free radical it will attack the alkene. So bromine free radical will attack. So it has also two possibilities. Either it will attach here and form a free radical here, and can attach here and form a free radical here. But the major product will be the free radical which has more stability. So which free radical has more stability? This free radical, because it has two alkyl groups from both sides to support. Okay, so this will be a minor product. Will neglect. This is the major free radical. Here, the hydrogen free radical will attack and form N. Just a minute. Okay. Here hydrogen will be attached and form a haloalkane. Notice, in absence of peroxide, the bromine will attach to the more substituted carbon atom. But in presence of a peroxide, bromine atom will be attached at the like less substituted carbon atom, the terminal position. Okay, this is called anti-Markovnikov rule. Only use this in case of peroxide. Okay. So in this question, reaction of HBr with propene in the presence of peroxide will be this product, that is N-propyl bromide. Okay. You don't have to do the mechanism, go through the just remember the mechanism. But for the exam point of view, you just have to find out the product, and for that you have to remember the rules, Markovnikov's rule and anti-Markovnikov's rule. Okay. Let's move on to question number 10. With respect to the conformers of ethane, which of the following statement is true? Okay, what is conformers? Let's draw a ethane. Let's draw a sawhorse like form. It is an ethane. Okay, these are the two carbon atoms, and these are the hydrogen here. Okay, so conformers are the stereoisomers, means the spatial arrangement of the hydrogen atoms or bond will be different. Okay, so let's fix this carbon atom and rotate this carbon atom. Okay, so if we rotate the carbon atom, here at position 1 the hydrogen bond are overlap. Okay, these bonds are overlapping for case 1. But if we start rotating this carbon atom, this hydrogen will be here and here and here and here. It will rotate, right? So it will no more overlap the first hydrogen atom. So because of the different spatial arrangement. So these forms are called as Q forms. Okay, these are the conformers. These are called Q forms. And the two extreme positions means overlapping position. And what will be the other extreme position? Let's draw. The other extreme position will be when the bonds will be on like this. Just a minute. When the bond will have opposite orientation with respect to each other. Like these two bonds have opposite 180-degree orientation. These two bonds have 180-degree orientation. These two bonds have 180-degree orientation. So this form is called as staggered, and this overlapping form is called as eclipsed. These are called as the conformers. Okay. So if one question asks, how many conformers can be there for a ethane molecule? How many? Your natural tendency would be three. That is eclipsed, Q forms, and staggered. But that is not the correct answer. The correct answer will be infinite because Q forms can be infinite. 1 degree, 2 degree, 0.5 degree. You can have many like infinite numbers of conformers at different angles. So, but these like infinite number of conformers have the same bond length and bond angles. Okay, they won't the bond angles and bond length won't change. If we have like here bond length is L, here also we'll have bond length L. It won't change. Okay, so correct option will be Both bond angles and bond length remains the same for all the conformers of ethane. Option C is correct. Geometrical isomers differing. So, what type of isomers is geometrical isomers? Geometrical isomers are a type of stereoisomers or spatial isomers, right? They differ in spatial arrangement of atoms. So, option C is correct because they are stereoisomers. Question number 12. It is asking in preparation of alkene from alcohol using Al2O3, which is effective factor. Okay, so let's write the like equation for this reaction from alcohol. Let's suppose the alcohol is our CH2OH. Okay, Al2O3 can be given at two different temperatures. That is Al2O3 at 350 degree to 380 degree Celsius, or it can be given at Al2O3 220 degree Celsius to 250 degrees Celsius. In these two different temperature ranges, there will be different products from this single alcohol. For the higher temperature range, that is 350 degrees Celsius to 380 degrees Celsius, there will be an alkene as a product. Okay, there will be production of alkene. Who is alkene? RCH. Okay, but for a lower temperature range, that is from 220 degrees Celsius to 250 degrees Celsius, there will be a formation of ether, which for this molecule, there will be formation of C2H5O, C2H5R. This ether will be found for this compound. Okay, so which is the major factor? It is it L2O3 or pressure or volume or temperature? It is temperature. By changing the temperature, we can like change the major product. Okay, for higher temperature, it will form a alkene. For lower temperature, it will form an ether. Remember the concept. Okay, so question number 12 is done. That is, answer will be temperature. Okay, which of the following reagents convert propane to one propanol? Let's go one by one. Propene, that is propene to one propanol. Okay, do you remember the Markovnikov and anti-Markovnikov I told earlier? Just told 2 to 3 questions before. Okay. For hydrolysis of alkene, also we use anti-Markovnikov's and Markovnikov's route. For H2O, for hydrolysis with the reagent H2O, H2SO4, we'll use Markovnikov's route. Okay. So the OH here will be attached to the more substituted carbon atom. So alkene will be alkene in presence of H2O, H2SO4 will produce this alcohol as a major product. Okay, that is two like propan-2-ol. Then option B, aqueous KOH. It will also produce Markovnikov product. That is propene H2O, H2SO. Sorry, aqueous KOH. It will also produce Markovnikov. product, that is propan 2. Then option C also will produce this product. Okay, in the presence of MgSO4, NaBH4H2. You have to remember the like reactions. Okay, now you have to remember the mechanism so that you can easily determine the products. Option D, that is B2H6 H2O2 OH minus. This reaction is known as hydroboration oxidation reaction. Okay, for this reaction, a mechanism is a longer, like there is a longer mechanism present, but I will tell you a shorter form. Okay, so in the first step, there will be hydroboration. That means the alkene here, alkene is propane, alkene is propane. So alkene will be, sorry, alkene propane. There will be six molecules of propane will react with B2S6. Hydroboration of B2S6, because there will be addition of boron atoms to this compound. B2S6 will react and produce 2 CH3 CH2 CH2 whole 3 B. Okay, this will be produced, means to each boron atom there will be three substitution, that is CH3 CH2 CH2, there will be three alkyl groups. This is the first step, that is hydroboration. Then oxidation or hydrolysis will react H2O2 in presence of OH minus. It will produce, it will replace the boron. Okay, it will replace the boron and produce six molecules of CH3 CH2 CH2 OH. This is the oxidation or hydrolysis part. And 2H3 BO3. Okay, so this reaction is known as hydroboration oxidation. If you can see here, the hydroxy or alcohol group is present at the anti-Markovnikov position, that is less substituted carbon atom. So for all the first three reagents, there will be a Markovnikov product, but the last option, that is B2H6 H2O2 OH minus reaction, there will be anti-Markovnikov product. Okay, so option D will produce 1 propanol. Okay, so let's move on to question number 14. Correct order of stability is, okay, for the like for finding the stability of alkenes, what is the major component? What is the major factor? That is hyperconjugation. For stability of alkenes, we have to know the hyperconjugation concept. Do you know the hyperconjugation part? Okay, so let's see here. There is a double bond, and here a hydrogen atom. So these sigma hydrogen bonds, that is at alpha carbon atoms, this is the alpha carbon atom. The hydrogen bonds, means the carbon hydrogen bonds present at the alpha carbon atoms will be in conjugation with the double bonds. Okay, this sigma bond will break and it will, the electrons will be transferred here, and the double bond electrons will be transferred to this carbon atom. So the more the hyperconjugation, the more the stable the molecule. And how will you find which molecule have more hyperconjugation? For that matter, we have to find the alpha hydrogen numbers. Higher the alpha hydrogen number, higher will be the hyperconjugation and higher will be the stability. Okay, so let's find out for these molecules, that is cis-2-butene. Cis-2-butene, let's draw cis-2-butene, CH3, CH3, So what is the alpha carbon here? Alpha carbon is here. These are the alpha carbon. And how many alpha carbons are there? Alpha hydrogens are there. There are six alpha hydrogens. Okay. So for me, one butene. One butene means this. For this double bond, this is the alpha carbon, and there are two alpha hydrogens. So alpha hydrogen two. C, trans two butene. So for this double bond, there is two alpha carbons and six alpha hydrogens. So C options like molecule A and molecule C have each like alpha hydrogen six. Okay, each have alpha hydrogen six, but molecule B has two alpha hydrogens. Okay, so the more like option A and C will be more stable than the option B. But we have to decide between A and C. Like option not like molecule A and C. Both have same alpha hydrogen. So we have to decide based on the position now. Okay. So the like in cis, the CH3 CH3 molecules are a little closer. So there will be more repulsion. But in trans, they are far away. So there will be lesser repulsion. So options like the molecule C will be more stable than the molecule A. Means trans molecule will be more stable than the like the cis molecule because of their position, because of less repulsive force. So the sequence will be C, A, B. That is trans, cis, and one butane. Option. So here option B is in this like sequence. That is trans two butane, cis two butane, and one butane. So option B will be correct. Let's move on to question number 15. In reaction sequence, let's write the reaction. CH2 hypochlorous acid gives rise to M. M reacts with R, gives rise to CH2OH, CH2OH. Okay, that is glycol. CH2, CH2 reacts with hypochlorous acid, that is HOCl. What will it produce? What will be the M compound? It will divide as OH minus Cl plus, and it will produce CH2OH, CH2Cl. This compound reacts with reagent R to produce CH2OH, CH2OH. So in this reaction, we have to replace the chloride atom. So to replace chloride atom, we'll add Na, that is sodium bicarbonate. Okay, it will add an extra OH atom here. You'll learn this in the aldehyde chapter of class 12. But remember the reagent NaHCO3, aqueous NaHCO3. So M is this compound and R is aqueous NaHCO3. So option C is correct. That is CH2Cl, CH2OH is M, and aqueous NaHCO3 is R. Question number 16. In the presence of platinum catalyst, hydrocarbon A adds hydrogen to form N-hexane. When hydrogen bromide is added to A instead of hydrogen, only a single bromo compound is formed. Which of the following is A? Okay, let's find out. Look, for option A, the question is asking if the compound A is given. If we hydrogenate it, Okay. For the compound A, if we hydrogenate it, it will form N hexane. Okay. But similarly, if we add HBr in this, it will form only one product. Okay. Let's go one by one. Okay. Option A compound will produce N-hexane. Yeah, it will produce N-hexane. Then add HBr to it. If we add HBr to option A, that will produce CH3CH2, CHBr, CHCH2, CH3. Okay. It can be in this position also. CH3, CH2, CH, Br, sorry, H, CH, Br. But notice these two compounds are same because from this side also bromine position is 3 and this side also bromine position is 3. So it is a one product, not two. Okay. So it is satisfying the question. But let us check the other options also. We got our answer in the first option itself, but let's check the other three options. Option B has it will produce n-hexane. Yes, it will produce n-hexane. So let's add HBr to it. It will if we add HBr to it, it can produce bromine in this position, or it can produce bromine in this position. Okay, so it is a different compound, and it is a if bromine attaches to this position, it will be a different compound. So it is not satisfying the question. So option B is incorrect, as it is producing two different compounds. Option C, option C is same that of B. Okay, look at the position of double bond. It is at the same position, that is second position. So option C will also be incorrect. For option D, if we add HBr to it, if we hydrogenate it, it will produce N-hexane. But let's here. So if we add HBr to it, it will produce CH2Br, CH2, 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 CH3. Or it can produce in this position, or bromine can attach in this position also. So it can produce CH3, CHBr, CH2, 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 CH3. Okay. So there will be two compounds formed in this reaction. Okay. So option D is also not correct as it is forming two different compounds. So option A is the correct option here. Okay. So we'll wrap up our session here. We'll see the rest of the 19 question tomorrow. So let's end this session here. Thank you.